Good afternoon, everybody. We are delighted that you could join us today for a special event. We have here in the School of Engineering Education, we are striking up a stronger relationship with friends from University College London. And so we have a delegation of 6 folks here with us today. They are kind of scattered around the room. Hello over there. Hello over here. As part of this, oh, and there's one. Hello, Liz. And as part of this, we wanted to invite John Mitchell to give a talk about some of the collective work that they have been working on for some years now, related to curricular, what I think of as revolution or transformation. And so John is going to talk a little bit about that work. This is part of a longer-term discussion and relationship we've had with UCL. We've had folks go visit them for research stays. We went to visit them to build relationship back in December. Now they are here, and we're hoping that we're building towards even more frequent and more kind of widespread collaboration in terms of exchanges of people and ideas and research collaboration and so forth. So we're thrilled that they have joined us today. Let me give you a few brief highlights about John. So John is, I'm going to read it from his bio, Professor of Communications Systems Engineering, and he's head of the UCL Department of Electronic and Electrical Engineering. And notably here, he's the co-director of the UCL Center for Engineering Education. And I heard you say earlier today that the transformation came first and the center emerged from that rather than the other way around, which is fascinating. John has held lots of different roles and achieved lots of accolades throughout his career. A couple of the key ones, he was part of the team that was awarded the HEA Collaborative Award for Teaching Excellence in 2018. He served as the Vice Dean Education of the UCL Faculty of Engineering Sciences, Chartered Engineer, Fellow of the Institution of Engineering and Technology, Senior Member of IEEE, Principal Fellow of the Higher Education Academy. Should I go on? All around wonderful, wonderful colleague and collaborator, wonderful human being too. So without further ado, let me turn this over to John to give you a talk about his experience and what he's been able to accomplish. And we'll have a little Q&A afterwards.
Thank you very much. Thank you.
Glad you're here.
So thank you so very much for attending today. And it is a real delight to be here and to visit Purdue. Partially because actually when we started this process, and one of the things I hope will come out is we wanted this to be very evidence-led and driven from research. And so, actually I see people like Brent, like Matt, whose papers we were reading to give us context to what we were doing and to help understand the research that would back the educational change. So I hope in this I'll just first say a little bit about UCL, just to give you some context and the faculty, a little bit about the changes we put in place, and also a little bit about the change management process, although slightly light-hearted in the way we actually developed change and got what was quite significant change within the program. Now for the contractually obliged slides on UCL that I think I have to give out. We were the 3rd university in England after Oxford and Cambridge at a time when you needed to be male, you needed to be a member of the Church of England, and you needed to be rich to attend a university in England. We attempted to address the first 2. It's not entirely sure we've done the 3rd, but 2 out of 3 is not bad. And we were formed in London and gained the moniker of the godless of Gower Street because our founding ideology was that of anyone of any religion or no religion could join the university. And we're very proud, more proud than we perhaps should be of our ranking in the world. As well as the scale. We are now the largest campus university in the UK, 51,000 students, only surpassed by the Open University, and very much a research-intensive university. Research very much comes first and foremost, which can both be a blessing and a curse for education, as I'm sure those in research-intensive universities know only too well. The engineering faculty, of which I am a member, is around 8,500 students in total and has grown significantly in the last few years, which I put for comparison. And we are made up of 10 departments. So this, I guess, would be the College of Engineering equivalent in your language. Biochemical engineering, chemical, civil, computer science, electronic and electrical, mechanical, medical physics, biomedical engineering, and also departments of science, technology, engineering and public policy, which is a relatively new department working at that interface of technology and public policy, security and crime science, and slightly strangely a school of management, which grew out of a technology entrepreneurship centre, but is now effectively our business school and is actually the largest of the faculty. And as you'll see, we have what for many universities in the UK would be seen as a very good staff-student ratio. Of course, all statistics belie some sort of lie and dishonesty. Whether all of those staff actually ever see a student is a different question, being a research intensive. And you will also see a very high overseas student number. We are in the sort of top quartile in the UK for the number of overseas students. And also quite proud of, I think I would say we are one of the least worst for gender balance of the engineering schools in the UK. And of recently, we're centred in Bloomsbury, right in the heart of the West End of London, in some of the most expensive real estate on the planet, which again has its issues, and our space constraints are something that we could talk at length, which I'm delighted to see you don't quite have the same issues here. And partly to deal with that, we've just opened a new campus of about 4,000 students out on the former Olympic Park, which is about a mile away from the central London Bloomsbury campus. And so you can see the Mitel orbit just on the side there. That was for the London Olympic Games in 2012, and we now have 2 buildings and 5 more to come on that site there. So what I actually wanted to talk about today was what we call the Integrated Engineering Programme, a programme that started in 2014 after 2 years of faculty review and development from 2012 and 2013, that started with some basic requirements, basic desires. One that we talk about now, but was a little bit implicit at the time, was an idea to be distinctive. There's another technical college in London that tends to get a lot of the prestige that's down in South Kensington, and so there was a desire from the dean to look different, to actually not necessarily compete directly. That's never always a good idea, but to say actually to students, there's that sort of education and this sort of education, and which do you want to have? This is very practical, very project-based. Very active, good theoretical education. And our dean was once asked, is that saying that school's not good anymore? And he said, no, they turn out many wonderful engineers. And our students will employ many of them in the course of their careers, which I think actually neatly sums up what he was trying to achieve with this revision. And to be modular, to be modern, to think about actually the challenges of the latter half of the 21st century are going to need from our graduates. That in the world of work, we were seeing that the disciplines were blurring, were merging. The idea of you could be just solid in one discipline is still necessary, and disciplinary roles still remain, but actually that many of the industrial roles we were seeing were blurring those boundaries of the disciplines and were happening in between disciplines. And so a need for curriculum that still played to our strong disciplinary base, but also exposed students to a much broader range of experience between the disciplines. And brought in professional skills, responsibilities, and we've often talked a phrase about globally responsible engineers. We want students who are technically competent but also globally responsible in their outlook to the way they design and solve engineering problems. So there were 5 core elements we brought in this, and I should probably just pause to remark, we decided, slightly madly in hindsight, that we were going, at the end of this 2 years, to completely change all 8 undergraduate programs over the course of 1 year and roll it out. So 1 year, 1,000 students came into the old program. The next year, 1,000 students came into this completely new program that we then worked through over the course of 4 years of the program. And it was a program that had a variety of projects, from small-scale projects to very large-scale projects, had a very strong thread of design central to the engineering practice, allowed students to work with different disciplines, while remaining that they were the disciplinary experts, but put them in experiences where they worked with other engineers from other programs. And we wanted to change the way we taught mathematics. And I'll touch on this again, because this is, I think, one of the key supporting elements of, we had a maths program that was predominantly taught by the maths department, was very theoretical, provided solutions to equations. We wanted to change maths into something that was, and all elements of the program, that were very closely linked to practice. And so students, right from the first learning they had, could understand why I'm learning this thing. I think one of the accusations we had, the talk of the math science death march of, we spend a lot of the first 2 years originally telling students, you just need to know this, it will be good for you sometime in the future, possibly. We wanted to bring those two things closer together, that you learnt this and then you applied it, and those two things were much more explicitly linked. As is required these days, very much a focus on student employability, because our students are demanding this, and an idea of some individual development. We also wanted, and this came from some of our, particularly our sort of K-12 work, to change the view of what it was to come in and be an engineer. Certainly at that stage we used to use slides where if you Googled engineer you found white men in hard hats and high-vis jackets predominantly. And as part of the program we wanted to change the view of what it is that engineers do and make that very evident to the students as they prepare to come in and as they come in, that the sort of projects they're going to do are very much reflective of a very diverse view of engineering. I have some particular views on what I mean by diversity, and I mean it in the very global sense. I'm quite against some of the programs that look at particular demographic groups and suggest that we throw more of these students in, and by adding more of a particular demographic we'll sort an issue out. I sort of feel we need to design a program that is inclusive for everyone at the very beginning. And part of that was that we were attracting students, as many engineering schools were, that were good at solving equations. That seemed to be the primary thing we cared about. If you had good maths, you were good to be an engineer. You were creative? Well, we don't quite know what to do with that. And personally, it's much easier to teach people maths than it is to teach them creativity. So we wanted to attract creative people into engineering. So a few of the things that this brought about. One was a lot more project work. So these are projects that are undertaken in the first 2 years, and all the programs have a series of projects, and they are designed to be authentic. So my colleague Emanuela was brought in to lead this with an industrial background, a consulting engineering background, and the idea was to try and mimic that type of structure within the way we develop these programs, that they mimicked industry. And we can talk a lot more about what authenticity actually means. And so we have scenarios, and I'll show you a schema later on, but this is an example of one of the scenarios. These are week-long projects where students go through design, build experiences that are generally based off of some of the courses that they would have been taught. So we teach content for a period of 4 or 5 weeks, and then they're given a project. And they're usually meant to be a bit of fun in the end. There's a serious side and a fun side. This is one of the IMechE challenges where students have to design a robot that climbs inside a tube and then returns gracefully down. I like this video because it shows both the joy and the frustration of engineering within the case of 30 seconds. This is what real engineering is like. The whole gamut of emotions. So the course before we started was looked like this. I'm not sure whether this was a Freudian slip that I made them all grey. Some people would call them silos. I believe Daniel Hastings of MIT referred to them as cylinders of excellence, but that's We had very, very separate degree programs, didn't really share a lot of interest between them, didn't share modules, students really didn't cross over between them in a great deal. And so what the IEP brought in was this series of experiences that cross-cut these courses. So Engineering Challenges, which is a project-based module, my colleague Fiona there leads, which is the big project experience that they have in the first term. Design and Professional Skills, my colleague Chika leads, which is supporting that. So these two really came in parallel to give the students the skills to work well and support their projects and to actually do the projects, and mathematical modelling and analysis, which was our revision of the mathematics programme, which my colleague Abel developed at the time. And these are then flow into departments running scenarios, and these are often discipline specific. And we also introduced minors, the idea that students could move from their department and work in these interdisciplinary areas. So I'll unpick a few of these as we go on. This is a picture we often used partly to think of this from a student's eye view of how they progress through it, which I think my colleague Emanuela drew, although I always sort of rib her on this because it's not a very good engineering diagram. It's not to scale on the y-axis. It may be emotionally to scale for the students that the projects feel like the biggest element. In reality, the bottom part, really what we changed is about 15 to 20%. Actually, that discipline technical line is still 80% of the degree. It's still by far the biggest element. But actually, I think, joking aside, this is actually representative of the feel of the students. And the students feel these projects as something really central to part of it, that this is the bit where it all comes together. And although they're doing these lectures, it's not that I'm doing 8 boxes of things that are separate knowledge that just sort of disappear off at the end. I'm learning stuff to deal with the projects as I go through. And so it's quite a nice example of how actually, without throwing everything out and starting again from a blank sheet of paper, which is just far too scary for most people, you can create a thread that gives a different feel to the students, that there is this purpose for the learning. We're learning, we're applying, and we've been doing some research now with our alumni, and that thread is what they remember. We've asked them what they remember of what were the key experiences of their learning, and you know, that middle section is what they all talk about. I should also mention one of the final elements, which was our sort of capstone of the first 2 years, a project we call How to Change the World. We used to have a strapline of Change the World for the faculty, and there was a bit of a joke going around that we say change the world, we don't teach the students how to change the world. And it was how to change it started as a title of How to Change the World ethically, responsibly, and via innovation. But as you can imagine, that got curtailed to How to Change the World fairly quickly. But this is a 2-week interdisciplinary project with around 1,000 students, with usually 4 or 5 projects, sometimes less, that are around UN sustainability goals. And students will work in teams from across different departments, usually that people they've never really met or interacted with, over the course of 2 weeks to develop a solution to a problem, usually set by a non-governmental body or a charity body. So these are real wicked problems. They're not, as one student said, they're not Googleable. These are things that even the people who are paid to solve this do not have answers to at the time. And we hear from students all the time that this is something, particularly in interviews, that they talk about the most. As soon as people, which is part of the reason I've learned to love the How to Change the World title, is that if people put it on CVs, people want to know what on earth is that? The other thing I probably should remark that comes in, you've got to remember, this is at scale. As I say, How to Change the World is now 1,000 students. I think this was the first run of How to Change the World in our largest lecture theatre, which is 936 seats. So yeah, this can be done at scale. It gets a bit complex at scale. We discovered one year that our institutional student management system only knows 999 students on a module. That was awkward. No one had ever tested that before until Fiona managed to one year. These are the things you learn. The other area I just want to mention briefly is the mathematical modelling, because this was something that wasn't, like some of the others, there's quite the step change immediately, but has really grown into something over the course of the 10 years as it's evolved. Around an idea that actually we want engineers who see maths as a central tool in everything they do in engineering design, not something that is separate to the processes that they learn. And so now our maths topics are taught each with a scenario. So when you teach complex numbers, it's in the context of designing a microphone. When you're looking at differential equations, it's in the context of sustainable coffee farming in Brazil. And we teach it via lectures, which are now, since COVID, all pre-recorded with the worksheets that step students through the key learning. Workshops, each of which are organised by the departments, so you'd learn differential equations, and the electronic engineers might give you problems about LCR circuits, whereas the mechanical engineers might use them for spring dampers, for example, and very much centred on MATLAB. And I've already had a few conversations about, I see MATLAB as a glorified calculator, not a programming language. It's a mathematical tool for creating models of the real world using mathematics that allow you to solve problems. And so we upgraded our MATLAB license and got every student to install it on their desktop and told them, when you have a problem, you should go to MATLAB and build a model to try and model it and solve it. So the last thing, the last element which goes through our second and third year was we had a history of elective modules, as most schools would do, and generally students being fairly scattergun in their approach to choosing electives. You know, the number of times I would be asked, which is the easiest elective, or which one am I going to get the highest marks in, or and also complaints from people with electives that, well, we can't do any of the really interesting ones because they haven't got the right prerequisites. They need to do that before they could do this really interesting one. So all of these are effectively 3 modules, so it would be equivalent, I guess, of three of your 3 credit hours across the second year and third year that students can do. And over time, these sort of developed into these interdisciplinary areas. And so the only requirement is you can't put any prerequisites on, so you can't ban any set of students from doing it, and they should be something that is generally open to everyone. So there are some, and you'll find some, applied chemistry has mostly chemical engineers on it, but not exclusively. And we're also seeing now, looking at alumni and looking at their LinkedIn profile, although this doesn't actually go on their degrees transcripts, many are using these to differentiate themselves and particularly bring their degree into a particular sector. And it was sort of by chance that many of these have sort of aligned themselves with industry sectors. And now we now bring industry in to talk about some of these areas. And so you'll see, particularly, I see a lot of students with, I did mechanical engineering with data science, and they sort of slightly bastardize their degree titles when they put them on LinkedIn to bring some of these evidence out. Civil engineering with environmental engineering is a very common one as well. So if I wanted to sum up some of those things that happened, I'd sort of really put it like this, that we are looking to bring this wider set of skills, the principles of science together, and really get students to think about designing sustainable students as this thread that runs through, and think technical. And I've often talked about, we often talk about the fact that, we've, in designing some of the experiences students get, there's 2 sides to any coin of things, in that it's great to have projects that have a sustainable context. And that's a necessary part of learning about sustainability. But it isn't the only thing. Actually, you need to understand what tools you need to be sustainable. You need to think about your thermodynamics and what that means for being sustainable. You need to be taught the tools so that when you see the context that requires you to be sustainable, you know what that's going to do. So I hope that's given a flavour of some of the changes. Part 2 of the talk is a little bit about some of the challenges and perhaps some of the strategies we use to get change enacted. As I sort of alluded to, UCL's a research-intensive university. It prides itself on its research excellence. It has good educational outcomes by the metrics we've historically cared about. which are that we get more students than we need applying to us, and the majority of them graduate at the other end. And by those two metrics, we were doing quite well, and that for a long time satisfied most people. So I'll tell you a little bit of the history of this. And we had a dean who, as deans do, go away to Global Engineering Deans Convention. I think it may actually have been in Chicago. So, and when he was there, he experienced people like Rick Miller from Olin, and I think maybe PK from here even, and others who tend to frequent those sorts of things, and came back to London all excited. Now, for those of you who've ever been a vice dean or associate dean, excitable deans are a risky business. And so one Sunday afternoon, he sent out an email saying that I really want significant change in the undergraduates. We want a complete revision, set out some of these principles about project-based learning and one thing and another. And as a software engineer, I think like that, I thought, well, they might not understand what they mean. So I'm also going to put a spreadsheet together of what their courses might look like after this transformation has gone, just to give them an idea of what this might be, and sent this out. He now will tell you that it was to spark debate, and I can tell you it certainly did that. The email threads lit up and everything. And eventually they put out a call for someone to lead this, and I'd been experimenting with problem-based learning. We'd done some scenarios in my department, and so I put myself forward to lead it, and was offered the job. Effectively 2 years to make a major change. And as I'll say, at the time I saw this as a change management program. We had a thing, and we wanted a slightly different thing, and my job was to take this from here, put it there, and then I could walk away and go back to being a research active electronic engineer, and it would all stay where I left it. I think we very quickly realized that that wasn't going to be the case. But over that, I learned a lot about some of the things that you need to do, or that we needed to do at least to make that change. And a few pieces of advice. And so this bit of the talk comes from sort of often when I'm talking to those that are thinking about leading educational change, what is needed for it. Talking to lots of people is absolutely critical. Understanding the very different highlights that people have, the concerns they have, where their red lines are, what the issues are going to be. So the number of people I took for coffee or took for lunch, depending on how serious their concerns were, was quite significant over the course of about the first year when we were doing this. We also, from an institutional perspective, I certainly found, and one of the best pieces of advice I was given, was that committees don't like surprises. If you throw a form over the fence for a change that they don't understand, invariably it gets thrown back. And I think it may be a thing in certainly many universities, it's certainly true at UCL and many others I've talked to, that actually the people who are in the administration are good people. They want to see positive things happen. They've got regulations and rules that need to be abided by, but they want to see things progress, and they are interested at heart of doing the right thing. And actually engaging with them, I found on many occasions people would look at me slightly strangely and go, oh, I'm not sure you could do that. But would this work? Or is that possible? Or could you do it like this? And so certainly through those conversations, we found a lot of things that were possible. There was a caveat from my former vice dean at the time about you do have to be a little bit careful with talking to so many people because you will hear so many examples. So he wrote me this list. The 3 categories. There will always be those that you must talk to. It's understanding your community. And we should know this as engineers. We preach to our students, we need to understand our users. So we need to engage our users, our stakeholders in all senses in this and understand and try and build this collective. But there will be difficult decisions to make. I mean, the most difficult conversation that I think comes up is always the worry that we have packed curriculum. We have so much good stuff that our students need to know. We could go on forever adding more and more to our curriculum. In actual fact, we have. we had a conversation with the electronic engineers about what they thought was the last thing that they took out of their curriculum. And one colleague said Smith charts, and the other one went, yes, I saw you did that, so I put it back into my lecture because they need that. I think we decided the thermionic valve was the last thing we actually got rid of sometime in the 1970s. The list, of course, of things we've added, quantum, nanotechnology, huge fields we've added to the curriculum over the course of the last 20 years and haven't removed anything. And so there is always going to be a fear that you have to think about some sort of rationalization. And if you're going to want to bring in these other elements, you've got to make room for them. There's got to be some option. You know, all the good things we want about innovation, about systems thinking, about ethics, to bring these into the curriculum, you've got to find a way to find that space, and that's always going to be the challenge, to negotiate that. And particularly if you want to bring in something practical as well, that then is really going to challenge what your curriculum is going to be full of. So one of the exercises we did, and I sort of got known for my large post-it notes, was this, you know, really go through to full curriculum mapping of what it is that our students learn. And I was slightly intrigued to find out that actually this isn't something that really happens that often. You know, people understand areas of their curriculum perhaps, or, you know, it was actually quite rare to find any member of staff who really had this mental picture of everything that was in the curriculum. Maybe a director of studies knew the whole thing intimately, but a lot of the staff didn't. And we found lots of very strange things going on. We'd do this exercise where we'd map out the entire syllabus on post-it notes and bring the teaching team in, and you could see them aghast at all this stuff that was on the wall. And they go, what is this? Yeah, well, this is your first 2 years. This is what you say you teach them. And you'd then get the strange questions like, well, why have you got that 4 times? And it's like, well, you say you teach it in 4 different modules. Or, you know, why is this still there? Why is that? Why have we not done this? So I think there is a refresh, and certainly we went through this process of really quite intimately looking at our curriculum and making some difficult choices about what is in and what is out and what is necessary, and very much also what is necessary to support what. And I think part of the reason we talk about an integrated curriculum is we think this is mutually supportive. And at the end of the day, I think we have to take a view that we have great students. You have great students, we have great students. They're going to have to learn stuff in their lives. We cannot teach them everything. These are not finished items that go off and never learn anything else in the world. We are preparing them to learn. There are things we must do within that context. Core knowledge we must add. Although, again, in an AI world, we're renegotiating what fundamental knowledge in our fields actually is. That's, I think, a conversation we're sort of starting in the early days of, but we really have to have of what is fundamental to a discipline to know anymore, when knowledge is not the gatekeeper that it used to be to a discipline. So there are these processes, but the advice to anyone leading change is, talk to people, but be careful who you listen to. I was told all of these at one point or another. Regulations won't allow it. Well, regulations are interpreted. People see it in different ways. It will take years. Well, things take often as long as you're allowed to let them. You won't get the space. Now, that may have been true, actually, to be fair. That certainly is our problem, that we challenge the space. I mean, many of our first years have their first project experience in a ballroom with Art Deco features, hired from a local hotel because it's the only place big enough to flat space we can put them in, which is not really an ideal learning environment. But so that's one of the things to do. So, if I could summarize some of that about what you need to make change happen. We had a number of weapons. Fear. There's a nice report from Ruth Graham about how the majority of educational change happens in response to a crisis. And in educational leadership, if you don't have a crisis, it's usually fairly easy to manufacture one. So there are always options. But I don't actually entirely mean fear in that particular way. I think much of the fear that we had was in a set of staff who wanted to do better, who felt that actually they weren't doing as well as they could do by their students. And actually, I think the fear that we are not preparing our students for the world was actually a key driver amongst this core group of staff that led much of the change. That we knew we could, we were turning out good graduates, they were getting great jobs, they were going on to good things, there were no great concerns, but we could do better. The world was changing and we needed to keep up. So fear was actually fear and surprise. I would think about, now surprise is an interesting one. And I say surprise when I talk to people thinking of leading change because actually you run a fine balance as a leader of change between consultation and collaborative design. And I've heard many people say we're going to have a collaborative design process. I'm sorry to be rude to some of my academic colleagues, but if you put 5 academics in a room, you generally end up with at least 10 opinions, often mostly contradictory with each other. It is very hard to design anything at this scale by committee. And so there is an element of talking to people, understanding, but I reached a point where it felt I needed to, you needed to go away and present a thing. And it suddenly, and people were quite shocked. They were very surprised from a number of conversations to something that looked like a really fully fledged design plan. The backstory to that is I presented this plan, everyone nodded, and I thought I'd won. We went away for an away day to flesh it all out, and they all turned up with copies of it absolutely covered in red pen and tore it absolutely to pieces. I went back to my office and half a bottle of very good whiskey later, I thought this was over, we're done, they're never going to accept this. But what I actually realized was that was the first draft of my thesis. You have doctoral students here, I'm sure. When you hand your first chapter over to your supervisor, it comes back in red pen. And this is the learning moment. You've got your engagement. They were now, actually that was the milestone. The biggest milestone was they'd read it. I'd got the engagement. We'd crossed that threshold now. We'd gone from the sort of passive nodding of, oh yeah, okay, is this ever going to happen? We've seen many ideas come and go and it's never, oh wow, this is a plan now. And that was really, really important. So fear, actually, fear, surprise, and an almost fanatical devotion to the dean. You need leadership, you need support. There are going to be problems. And one of the things we really needed was, and we remember from our first year, things will go wrong. And when you're doing things at scale, when things go wrong very noisily. 700 students in a chat room on a virtual learning environment when an assessment doesn't work. That's noisy. And you've got to have someone who trusts you and leadership that will have your back to say, no, it's not going to be perfect first time. We're going to hold our nerve. We've got to make changes. We've got to, we know we're doing the right thing. We know we've made, and one of the things we were actually talking with colleagues the other day, Manuela was talking about that we'd never really engaged our first year students in conversation and got feedback from them. And so we did an awful lot to get feedback. And of course some of our colleagues are going, we've never had feedback like this. It's like, well, you've never asked before. That was why you never got feedback like that. And we learnt a lot from it, positive and negative. So you need to have that leadership support that really supports the process at all levels to make sure it goes through. Well, you need to be devoted to the dean, of course. Now, I used to do this with our lanyard on. This was a bit of a throwaway to a structural issue, because one of the things that's going to determine the way you do this is the structures that you have. And we were going through a period where the engineering college or faculty of engineering, was really coming into existence as a major entity. We'd moved from the sort of early 2000s and historically where departments had been the centre of the universe. And there was really college, there was really the university, and then there were a lot of departments loosely collected around subject areas engineering, but I think the engineering was a figurehead dean and maybe one administrator. It was to actually the colleges being much more executive entities, controlling budgets and doing all sorts of things. And so one of the things that we often talk about in this is one of the things that drives what you can do, what you can't. Well, you can do anything. I often say, one of the great things at UCL is everything is possible, just some things are more difficult than others. What makes it more difficult is your structures will determine what's easier and what's difficult, how the money flows, who's got the decision-making powers, where you've already got structures that connect you. And so one of the things we talk about is actually having to build some of these structures. So apologies to Monty Python for those who recognise that bit. So there's a few lessons learned. We used a lot from precedent. And I think, if you were thinking of changes, you've got so much precedent here. By precedent, we mean actually we didn't do things that we didn't know. We picked from places on campus who were doing, maybe examples of one class, or we were using things that were known. Because it's very easy, and we talk to a lot of people who go to Olin College, for example, and see see the wonderful things they do. It's fabulous, fabulous engineering school. But if you've got an enrolment of 65 in purpose-built facilities, or you're in the centre of a metropolitan city with 1,000 students, that's very different. You can take inspiration, but you can't take that model directly across. And people look at you as if you're mad, going, well, but they're that, we're this. How is that going to square? So, and I don't know, this was necessarily always something we did implicitly, or explicitly. We took a lot from things that were going on. We took a lot of experience. And one of the biggest advantages of that is it meant when instructors saying, I don't know what this is, I don't know how that's going to work, you can take them into people's classroom. And it was amazing with the problem-based learning experiences and the scenarios. Before taking people into the classroom, you'd have these very pragmatic, logistical conversations about, now, how are we going to mark that? How are we going to organise the teams? How are we going to do that? They spend an afternoon working with the students in a class, and they'd come back and go, well, I could have a project that's in this, and it could do this, and I'm going to bring this client in to do that. Conversations changed completely, having touched it, felt it, experienced it, seen the students, and seen what students can do when put in that environment. Because I think that was another big thing for staff, that they weren't familiar with this way of learning, they'd not been taught that way. And they really worried about what the students would learn. Okay, yeah, they'll have fun designing something, but will they learn? And our experience was when you actually put them in that environment and they spent an afternoon with the students, they came away very enthused by it, that no, this is real learning. You can see them taking theory and understanding what that means. This is wonderful. But also remember, the students can be conservative too. You're a top university like us. Our students learnt to play the game. Now, they've got where they are by doing very well in tests predominantly. And you now try and tell them that tests don't matter as much. You've suddenly changed the rules of the game, and that can be difficult for them. These were both quotes from student staff committees. This wasn't what they expected an engineering degree to be like. They didn't expect to be put in teams. They didn't expect to be doing projects. They didn't expect this. Now, some students get it. Some students get it from the beginning, but quite a lot didn't. But the penny drops at various stages. We've seen as it goes on. Some get it when they come in, some after the first year. Most not necessarily until they get to the end and suddenly, going for job interviews and realise this is the stuff that employers ask about. They don't ask me to solve differential equations in my job interview. They ask me when I've worked in a team with other people. And at that point, it comes. So it happens at all stages, and we're getting a lot of a lot of feedback back from it. So. A few final thoughts. Change is hard, but it's not linear. It's harder to start change than it is to develop. And one of the things that we're now getting back 10 years on. People were telling us this is a once in a generation change. We're not changing anything again. So when you make a major change, you've got to lead it through. And I was in charge of the change. My colleague Emanuela now runs the program. It's very important that we, one of the things I didn't realise early on, but has become very important, is to build the structures to maintain it and to develop change. So this is something we've had to work a lot, because departments manage things, to manage and to control. But it has many, many advantages of being able to work across departments and spread good practice. So that's something we've certainly come out from. And now I think we see this as a cultural change. We've got teaching track staff who are affiliated to the centre, and as Ed said, the centre really grew up afterwards to help maintain this, to research this change, to support the staff who were involved in this change and bring them together in a community, but also to work with others that were looking at doing similar change. And so although this started as the integrated engineering programme, we now talk about the engineering education, integrated engineering philosophy, the idea that this is a way of teaching that we like our masters to bring in and to other areas. So, universities are a great place for change if you can work out how to do it. They are also inherently designed to stop change happening. That is what many of our processes are there, to keep things neatly in their slot. But it's a challenging yet a very rewarding option to try and change things. So thank you very much. Any questions?
All right. Yeah, thank you, John. We have a microphone. If you have a question, raise your hand. Happy to run around to you. All right. Oh, yes.
Wrong way.
Rebecca.
And I have to stay here because I don't have...
Yes, thank you so much for your talk. This was great, really inspiring. I'm an anthropology PhD student, and I've been working with the Innovation Hub and looking at transdisciplinary courses. But one of the things I'm really interested in is the space. You talked about and alluded to that, and so much of the learning environment happens in these spaces. And so I wondered if you might talk a little bit more what that looked like for change.
Yes, actually, one of it's not in this particular slide deck, one of the things we now often talk about is that actually any educational change, I think I stole it from your former colleague Alison Godwin, actually, was there is a concept of curriculum change, of culture change, and of the environment in which it goes. And actually those three go hand in hand. And I think if I was going to be critical of what we did, we knew we wanted to change the curriculum. We knew to do that we needed to change the culture. What we didn't pay enough attention to is what facilities you need to do this. And interestingly now, certainly in the UK, what we're seeing with some other schools that are making similar changes, actually it's often linked to a new building. So in the UK, Birmingham and University of Manchester have launched new programs that are very project-based, and they've launched it as part of moving into new facilities. And that would have been so much easier. We ended up doing some really, really stupid things of building big carts of equipment to take it around campus and all sorts of stuff. So I think, yes, we certainly underestimated that connection between do you have the right environment to promote this type of teaching? Because, I think many of us have struggled with a problem-based learning class in a tiered lecture theatre that just isn't conducive. But I guess, certainly a university that's in a metropolitan hub in some very old buildings that are really not fit for purpose, we're 10 years behind where we need to be to start converting space into, not so many lecture theatres, more flat space. And, unfortunately, the education, it's a sort of, I guess, a problem of, the university isn't changing the space until it knows it needs to change the space, and by the time it knows it needs to change the space, you need the space, but it's going to take 5 years. So we're very much stuck in that. But I think if I was advising anyone thinking about what the environment is and how you manage that against the culture and the curriculum is very important to really cement a change.
It was lovely to hear you talk about your experiences, and at one point in time, one of our deans had asked us to think about bringing math into the College of Engineering, and that would be a huge headache here in a really practical way. So can you talk about the practicalities of so for us, the math department serves
Yep.
our students, so it also in some ways justifies their size and existence, right? So how did you play that game so that it
Yep.
worked without harming them, and at the same time got what you wanted happen?
Yeah. I mean, that was a difficult discussion, I must admit, in that at the time, probably about 2/3 of our engineering courses were taught from the maths department. 2 departments had already taken maths in-house sometime earlier. We were fortunate at the time the maths department was looking to launch a new program of its own, and so it was actually discussing its resource. And I think it was quite convenient that, although actually they did end up taking a financial hit, we have a financial model where money follows the students, and so probably best part of $2 million in student fees changed between faculties on the basis of the maths program moving. But they were actually looking to realign and develop their own program, so there was some benefit for them at the time. I think if it had ended up being more hostile, it would have been a very difficult thing, because it would have changed staffing levels and things in quite a different way. So, it's a delicate negotiation, and that's usually the one point in the slide that comes up more than ever. There's more than one university I've given this talk to who have seen it. Someone has seen it before, and they said, "Can you not mention the maths bit?" Which I usually agree to. But yeah, it is difficult. I mean, there are other models that I've seen people do. I mean, I think if it had been different, the model we probably would have ended up with is far better integration. Because I think actually what we did see at the time was that the maths department didn't really talk with the engineers. They had their set course that they'd been teaching since the 1970s, and that's what engineers need, and that's what we do. So I think there are more collaborative models you could do, but at the time, actually it was a win for both, I think, to have the shift, so we took that opportunity. And I'm not sure they would have wanted to go quite as far as we have gone to almost drop the word maths from it and make it a modelling course that also teaches maths, which is what you need to do the modelling.
So, thank you. This was an awesome presentation, especially since you do that at scale. So I tried it in my semiconductor grad course, which is still more or less taught with textbooks from 1960s of equations that are completely irrelevant for today's design, but
Yes.
that's the only thing you can do analytically. And we take that analytics as a proxy to really do designs down the line,
Yes.
which is crazy. So I ripped out exams and I replaced them with projects in a virtual space on NanoHub, so I don't have to worry about space. But I ran into, so I have projects, 3-4 people, and once the class is small, you can put in a lot of night hours to grade it.
Yeah.
So I went to peer review grading, where they rate themselves and they rate each other, and they hate it.
Yes.
And you give them sort of a rubric where they can, that is expandable. And I see all the comments that you just showed, right? This is not engineering, or I'm surprised, the open-ended
Yes.
of this took over my life, this project, and it has an open end, right? Not a finite answer. So how do you do this grading? Because it was killing me until I went to peer review.
So, I mean, I'll give you an example. I mean, so 2 things you mentioned there, and I'll give you an example of how we sort of tried to deal with some of them. So that part of the reason that the scenarios came about, the 1-week intensive modules, intensive design experiences, was when I was doing problem-based learning, generally there would come a point where I would be ganged up on by many of my colleagues going, "You've got a deadline this week, haven't you? Because none of my students turned up to my lecture this morning. They were all doing your project. Could you stop that, please? So they need to come and learn some stuff." So that was one of the things. And I would just tongue-in-cheek, go back to them, well, they value my project more than your class. What can I do? Yeah. But that apparently wasn't a very good answer. So what we ended up doing was saying, well, actually, you learn, you do the theory, you learn stuff, and then we're going to stop. So you're not competing with classes, you're not skipping classes to do your project. The project starts 10 o'clock on a Monday morning, 2 o'clock on the Friday afternoon, you demo your solution to the project. And some of the first examples we had, we then asked them to write a report or write something up afterwards. And the problem with that was after an intensive week, none of the students could be bothered to write the report and none of the staff could be bothered to mark it because they'd both put their lives on hold for the week. And so we often went to much lighter touch assessment in that. And so we'd have teams of 4 and we'd say, you stand at a computer in the lab, you've got 4 slides, you need a slide on the design, you need a slide on the results, you need a slide on this, that, the other. And we'd walk around and write, your slide 1, your slide 2, your slide 3, your slide 4, go. We had iPads, we'd mark them live in there, ask them questions. So by 4:30, all the marks were uploaded in the virtual learning environment, and we were in the bar, and it was wonderful. So there are things you can do. You can do, particularly with projects. And I think one of the things I think be a bit inventive in. You can be a bit inventive in the way you assess projects much more, I think, than you can in theory. Now, many of our classes all still have exams, and so this is one of the tricks we have with project-based learning, or one of the difficulties we have. And what is quite nice about this model is that actually many of the core things we need to be very clear we examine, we do in exams at the end. We do in very much more traditional ways because we know each student is going to be assessed on it. And Karaya may look at me funnily when I say this. One of the problems with problem-based learning is you really can't guarantee what the students are going to learn. They're going to learn some good stuff. They're going to learn stuff. I just can't absolutely say it will be that thing, and that thing, unless I make the problem so much of a toy problem that it's really not a proper project anyway. And so part of the solution here is that actually we will not, because we're testing things elsewhere that are really important for us to test, we're not that worried about necessarily, okay, there's a circuits element to the project, that every student fully understands the circuits that are in the project. We try and do that by asking them to fill the slides, but we're a little bit less worried that every student has met every learning outcome that's in the project. But we know they'll get most of them, and probably some other things that we didn't expect as well. So, yeah, it gets a bit of a balance. But talk with Fiona, actually, because she does a lot of the assessment for the projects. I think we can have some discussion there.
Hi, thank you for your talk. It's great to know about this. And I have one question about the change. And
yes.
If this change have had an impact on how you were doing engineering education research, it's like facilitated, changed something, or maintain the same?
Has it facilitated? Well, I mean, I suppose the short answer is we really weren't doing engineering education research that much at the time. I think what it did do, however, was pull together, or actually brought that teaching team together that were interested in it, provided us with a great data set to mine for research. And I think, actually one of the big advantages is that the majority of the staff, okay, so the centre has 2 full-time dedicated researchers that support us, that's their full-time job. But most of the research output of the centre now is through staff who are also teaching on these programmes. And so it's very much practitioner-led research. And so I think that has been quite important for the centre, that we are engaging in that. And the centre is a mix of some staff who are predominantly in the centre, but that's a team of probably only about 12 or so. And then a very, very big network of the teaching track staff that are in the departments who sort of feel us as a second home to some degree in the centre, partly because we fund educational conferences and fund research projects and fund other things through some of the consultancy output of the centre. But we're a sort of home from home outside their departments for those that are developing, wanting to do research and wanting to develop. So I think there is, we've sort of formed our own style of how we do, but actually, much the centre came after the research, sort of came after the change to some degree, and is now there to both cement it and to evaluate it as it goes forward. And now we're getting into other areas as well to look forward. We're working with colleagues on the ethics and empathy and emotions, which are the next things we want, and now it's sort of a bit more the traditional way of we're going to research it and then try and bring it into the curriculum. But that's relatively new for us.
I think we have time for one last question.
I was hoping you could talk a little bit more about how you scale authentic learning to be accessible to students and sufficiently time constrained. You mentioned a little bit about like the weeks and the robot projects. Can you expand on that a little?
So again, how?
Making the authentic learning be something that's like a sufficiently short amount of time, sufficient difficulty level for students, that sort of thing.
Yes, I mean that is a real challenge, because there are certain things you can do, and it's partly why we have some different scales of projects, because there are some things you can't do in a week. The week is a hothouse experience. It's good for certain things, but you can't really get complex things manufactured. You can't order in components. You can't. Actually, the mechanical engineering example I showed with the thing going up there, that's quite a nice example of how you break that, because what they do actually is that's 2 weeks together. In the first week, they design it in CAD and test it in a simulation environment, and at the end they have to submit and they get their designs graded. Then in the subsequent 5 weeks, they get manufactured. And then the second week is the build, the invariably test, the invariably fix, and then the competition. So, you can be a little bit creative of doing things over 2 weeks, and that's something we've seen a bit. But yeah, there are certain types of projects and certain types of authenticity you can't have. But we also have longer projects. Part of the reason that the first project is a bit more spaced out is that's the first one the students do. And so you want to be able to talk to them about teamwork skills and have a teamwork experience, get them to reflect on it. You need a bit more time. So I think there's horses for courses. There are some things the week is very good for, but it does limit some of the things you can do. It's hard to bring industry in that. We do some where we go to industry and they set the challenges. Chika can explain about the ice cream making, the improving the process of ice cream making. That's always a popular one with the biochemical engineers, where they go and visit an ice cream factory and get told about the problems they have in their manufacturing processes. So you can bring some of those things in like that. We probably do more of that in How to Change the World, which is 2 weeks. Although actually, interestingly, one of the things we've skipped away from, we started having industry start the project. And we found 2 things of that that weren't so good. One, industry brought their own biases of what the solution might be in. And 2, the students really, on that first day when they first got the project, haven't really got to a point where they ask sensible questions. So what we do now is actually they come in the second Monday and critique the design brief that the students have developed and their initial ideas. And that works much better because they're at a point where they can have a much more informed conversation between the two, and the students have already formulated some of their ideas and are not being biased by, with the best will in the world, I want something that does this for me. A bit like that would be nice, sort of way that industry can sometimes present these ideas. So I think, you evolve, and there are possibilities to bring stuff in, but you have to be cognizant of the time frame.
All right, I think we are going to close it down there. Let's thank John once again.
Yeah, thank you.